Então, pessoal, estão aqui, diretamente do Twitter lá, Marcel e Angus, uma salva de palmas para eles. Serão duas palestras. A primeira palestra é a do Angus. Vamos começar.
No, I'm just going to use this. Okay, so hi everyone. I want to start off by apologizing for not speaking Portuguese. This is going to be in English. And I have a stutter too, as you can tell. So hopefully it won't take away too much from the presentation. So today I'm going to be talking about reuse patterns in JavaScript and why we settled on mixins for Twitter Flight. The most difficult bit of talking about JS inheritance is always what example to use. And here's a tweet I sent out some while ago. On the sixth day, God created an abundance of talking animals that they may be used in JavaScript inheritance examples. And that's pretty much how it is. Everyone uses talking animals, and I hoped by sending this tweet out that someone would convince me of something else I could use as an example instead. But all I got was a lot of retweets and favorites, and so because of that, it's going to be talking animals. Yeah. So before I talk about reuse patterns, just a very brief introduction to Flight, which is Twitter's front-end framework. And if you want to know more, you can go to the site, which is there. And Flight powers a few sites, twitter.com and TweetDeck. It's interesting because at Twitter, we render our content on the server. TweetDeck is rendered on the client, but both use Flight. And to show how adaptable it is to either model, it's used at some other companies too. And very short summary, Flight is a set of components which bind functionality to HOM nodes. So you have discrete functionality which applies to an element in the page. So for example, this is the sample app that comes with Flight. It's an email client, and we can identify some components there. So there'll be the list of emails, actions at the top, where you want to move the email to the folder list and the new button. So we would have a component for each of those, and it's a discrete set of functionality for each. And the key to this is that components are completely decoupled from each other. Even if you wanted to reference another component, you can't, because when we instantiate component instances, we don't track them. There's no global tracking. So when an action happens in a component, you trigger an event. You've no idea who's going to be listening to the event. You've no idea who you're talking to. So it communicates via event. Bubbling. And here's an example of that, again, from the sample app. So if you want to move, we've selected a couple of folders here, a couple of emails, we want to move them. And so this component triggers an event to say, I want to move to this folder, and whoever is interested is going to listen to the event. In this case, it's a data component, which is a sort of liaison between the UI and the server, and that listens to the event and does whatever it has to do. You could have multiple components all listening to the same thing. So components often share behaviors as common code, and rather than rewriting the code in each component, we need to have a reuse technique. And because at Twitter we built Flight from scratch, it gave us a good opportunity to survey all the reuse techniques in JavaScript and decide what we wanted to use. And so these are probably not all of them, but a bunch of reuse patterns that are available in JavaScript. And the ones I've highlighted are the ones I'm going to be talking about today. So let's start with classical inheritance. So you may or may not know, ES6 spec is going to give us an actual class. There's going to be a keyword for class. But until then, some libraries, third-party libraries, have implemented their own version of class. And that's kind of problematic for many reasons. Firstly, there's reserved words, class, extend, and super. So the libraries can't use those words, so they do things like class with a K and that sort of stuff. Implementation varies widely, and JavaScript doesn't really fit well with the semantics of class. There's usually keywords like constant, static, which kind of don't apply to JavaScript because it's a dynamic language, but libraries find themselves having to talk in those kind of terms. And in particular, the super keyword is very hard to implement. Here's a couple of examples of how it's proved really hard to implement. So the first one is from the prototype library, and basically you have to pass super in as a special argument every time you want to use it, which means they have to pass using a complicated regular expression. They have to pass all the code and wrap each function that has super in another function that removes the super argument. Here's another class library, and again it's the same kind of problem. This super is not actually referring to the method that you want to get the super of. It's referring to the object. In this case, it's the alien. So again, they have to pass this and they have to wrap it. So it's pretty awkward. Not very easy to write, not very easy to understand either. And then there's the question, do you even want classes? Does JavaScript even want classes? So here's the animals, and here's an animal hierarchy here, pretty standard. So animal is the grand superclass, and then you can have a walking animal, or a swimming animal, or a flying animal, and then there's various animals, subclasses of those things. So that all looks clear and easy until the crocodile comes along, and he says something which I can't say, and then he says, I walk too. I'm not just a swimming animal, I walk too. But classes, you can only inherit from one thing. And then the duck comes along, and the duck actually fits into all of these categories. So the duck can't deal with classical inheritance. So to summarize the issues with classical inheritance, it requires upfront knowledge of the general case. In other words, you start with the abstract superclass. You may really know nothing about it till you know what all your concrete classes are going to be, so it's hard to work that way. It's a single-rooted hierarchy. Again, you can only extend from one thing. And as humans, we're really bad at classification, and I think we overlook this point quite often, but we like to think we know what our objects are, what they're an instance of, but usually the class we choose is not sustainable, and we soon realize that actually, it's more than we thought, it has more behaviors than we thought, or it doesn't really inherit from this thing, or A that inherits from B, but B also needs to inherit from A or something like that. It gets very complicated, and we soon find out we're not as good at classification as we actually thought. So let's move on to constructor-prototype chaining. And this is strictly constructor-prototype chaining I'm talking about. Constructors and prototypes, they're fine and they're part of the language, and hopefully nobody has any problem. But when you chain prototypes, so to make an inheritance hierarchy from prototypes, that gets difficult. That's kind of awkward. Here's an example. So you need to explicitly make your subclass invoke the constructor of the superclass. And you also have to do this, which is basically seed the prototype of your subclass by creating a new instance of the superclass, which is pretty nasty because A, you may be tracking how many instances of animal you have, and you don't want to create arbitrary instances. B, you may require arguments in your constructor, and the code in the constructor may do something. So by not passing an argument, you risk throwing a reference error or something like it. And the other thing is, really, when you're using new constructor, you're using classical inheritance. People talk about JavaScript as prototypical inheritance and not classical. But this particular syntax, a constructor is a type, and a type is a class. You're forcing this classification thing, which we talked about before, and you end up with a chain of constructors, which is a chain of types, and you end up with an inheritance hierarchy in exactly the same way. So moving beyond classification, so back in the 19th century, two British philosophers, Whewell and Jevons, argued there are no right classifications. This is kind of what I talked about before. You can't really classify objects with any degree of confidence. And in fact, it's been said that prototypical inheritance is not about types, not about categories. It's about common behavior and just identifying common behavior and sharing it around. And luckily, in ES5, they introduced object create, which means you don't need a constructor. You don't need to define a type. So this is much more of a natural prototypal way. It's just saying this object is going to borrow or is going to use some behavior from this prototype. So here's an example. That's the animal prototype created, and you're just saying the walking animal prototype is going to inherit from the animal prototype. The only problem with object create, I think they overlooked the problem with the second argument. It could have been a simple object. Instead, it's an ES5 property, which means it's a hash of hashes, basically, which means sending dynamic properties as your second argument is very, very hard. And for me, at least, I find it very troublesome. It's made it a lot harder to use object create than I would have liked. And you've still got the problem you can only inherit from a single thing. So I think in JavaScript, it's sad that we even care about inheritance hierarchies, because they're not really necessary in JavaScript. In Java or C++, you can only use a function or property if it's in your hierarchy chain. Not the case in JavaScript. JavaScript has first-class functions. You can pass them around. You can use call and apply to call them in any context. So basically, any function can be assigned to any object. So the whole reason for having an inheritance hierarchy, I'd say, it's much less necessary than it is in a lot of other languages. People like them often because they come from other languages and they feel comfortable. So this is where mixins come in, and the mixin in its most conventional form is just an object. So here's the with walking mixin, which just defines a few methods that tell you how to walk. And then to use this property copy mixin, you'll need an extend function, which is basically a clone, just copies the properties from one object to another one. And now you can see we can make our crocodile walk and swim just simply by copying the contents of the with walking mixin and the with swimming mixin. So to review that, no hierarchical constraints. You can inherit from lots of things and wherever you want. There's no is-a relationship. We're not having to say crocodile is a walking animal or crocodile is a swimming animal. We're just saying, what do we want functionality-wise? What do we want? And you can define special cases, i.e. the crocodile or other animals first, and you can think about common code afterwards. But there is a problem with this. The thing you're mixing in must know about the target it's mixing into. Otherwise, you're going to clobber properties, potentially. Properties are arbitrarily named strings, so the target object may have a property with the same string name. And then you're in trouble because you've lost the original property from the target. So this is where functional mixins come in. Here's a functional mixin. So unlike the property copy mixin, which is just which is an object, this is a function, and you call the function in the context of the target object. So this, and this represent the target object that you want to mix into, and then to apply the mixin, you simply invoke that function. So you call it in the context of the thing you want to mix the properties into. So here we have the crocodile constructor, and this is common behavior. Stalk tourist is common behavior that all crocodiles do, and then we mix in some behavior there. And at Flight, we use functional mixins. That's what we decided, and it worked best for what we wanted to do. Here's an example of functional mixin usage in Flight. So again, from the sample app that ships with Flight. There's 3 components here. There's the emails, the change folder, and the folder list. And they all have select functionality. You can make a selection in any of those things. So it's common behavior. So rather than define it in every component, we wanted to mix in the select. And that's what we did. So again, it's a functional mixin. It's a function. This, and this represent the target object you're going to mix into. And so we were able to, this defined component is a bit of sugar that Flight supplies, but it's basically saying, this is the component, this is the mixin you want to mix in, and you can have as many arguments as you want, so you can mix in as many things as you want. This is just a simple example with only one mixin for each component. And so this is how we easily mix in select functionality to each of them. And then there's the advice mixin, and this addresses the issue of clobbering or not clobbering properties with the same name. So advice.js is a mixin, and it allows your mixin to customize the target code by adding code before, after, or around an existing function. And all Flight mixins get advice.js for free out of the box. So that way, your mixins, without having to know anything about what they're mixing into, can augment the functionality instead of clobbering it. Here's an example. Again, going back to the animals, and this is a crocodile. We're going to take an instance of the crocodile in this case. So the good thing about mixins, you can mix it into anything, into a prototype, into an instance, into a constructor even, I suppose, if you wanted to. And so here is a with flu mixin. We're going to give our crocodile flu, which is kind of sad, but I'm sorry. And so this is our crocodile instance we just created from the regular constructor. So this says, the with flu mixin says, before you're going to walk, you're going to sniff because it has a cold. And so and then when you mix that into walk, when the crocodile walks, it goes sniff, pad, 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 pad. So that's how that works. That's how advice works. And for example, if walk hadn't been defined on the target object, because we don't necessarily know, then okay, it doesn't walk, but it just sniffs. And so therefore the mixin is still working. And this is an example from Flight, how every Flight component has an initialize method which is executed on startup. We're just saying, the mixin is saying, after you initialize, select the item selector, which is a CSS selector defined by the component, And whenever it's clicked, for any of these components, toggle item select, in other words, either show or hide the selection. So this is a nice way of making the with select mixin do a toggle select without having to know anything about the component that it's mixing into. So at Twitter, why do we like functional mixins? Well, this is a brief summary. So the first is kind of a philosophical thing. It's a verb instead of a noun. You never need a mixin as a standalone object. Nobody really uses mixin standalone. It's a process. You want to augment some other object with the mixin. So to be a verb instead of a noun kind of makes sense. And mixins are functions, and functions are really good in JavaScript. They're first class, and you can take advantage of closure scope, and you can send arguments to them, so you can qualify the mixins too. And they can be applied to anything, as I showed, prototype or an instance or anything else. And the advice showed how you can use mixins to augment functions instead of cover them. And best of all, they work with the language. So there's no extend function required. There's none of that crazy prototype chaining stuff that we had to do with seeding the prototype with an instance of another prototype. There's none of the super issues that the class had. It's all pure JavaScript and nothing else required. So I think it makes them very easy to understand, and there are no surprises. And that's it. I'm not sure, do we have time for... Yeah, we got a little bit of time for any questions. Yeah. Do you want the microphone?
So at Twitter, you use advice to fix the problem of clobbering properties. But this only works when you want to extend the functionality that you already have, and not when two different interfaces conflict, like two separate interfaces with those two entirely different things define a method at the same name.
I see what you mean. So you mean if you'd accidentally given the same name to two different things, then you'd be adding functionality to the other one. Yeah, that could be a problem. It's, in a way, if you think about it, it's still kind of working. I'm not saying it's an ideal situation, but your target object is still going to execute the thing it wants to execute. And say you do after with the mixin, the mixin is still, after that, it's still executing the code. But I guess it's in the wrong place, because, yeah, so it could be a problem. Yeah.
Have you looked at traits or some other way for doing
yeah, we have. We just wanted to keep the code very, very simple. I think traits are coming into ES6 potentially. I'm not sure how that's actually looking right now.
I think they dropped it from
they dropped
ES6,
right.
but maybe in ES7.
I mean, it's definitely an issue. I mean, Twitter.com's a pretty big app, and we haven't yet had an issue with that, but I can see how it could be, and yeah.
Yeah. Thank you.
Okay, thank you. Is there anything else? Any other questions? Okay, thank you very much.